You know the thought of making things appear magically and not doing the mundane task again and again, something sort of a plugin which can generate things for you, designed for one specific task and make n number of iterations just by clicking few numbers. That's exactly what we are going to talk about today in this geometry node chapter and the next one. Generators. You can design your own generators with node groups, and yes, you don't need programming for this because that's what geometry node is designed for. You can design your own generators with node groups inside geometry nodes in Blender, which are procedural, easy to tweak. You can make adjustments and repurpose your model, save it to your asset library, and just click and drag next time you need the whole setup again. So now when thinking about generators, the first thing that comes to my mind is trees. So perfecting a tree is a difficult task. However, we are going to make a simple tree generator today, which is kind of convincing, at least for me. It looks like tree, right? And made possibly in the most dumbest way, without doing much of a complex math. Honestly, I hate math myself. So let's jump to Blender, and I'm using Blender 3.4.1, which is the latest release at this moment. So we can simply start with any sort of mesh, and that's because we are going to delete this one and bring another primitive here, which is curve circle. So this would be a good starting point because trees are vertical, tall, simple, cylindrical things. And in this one, if we fill curve, that's going to make this one solid, and this would be good enough to distribute some points which we need to form the main tree trunk. Then let's bring instances on points, and this way we can instance some curve lines here. So these could be around 10 meters tall. The tree could be 10 meters tall. Let's randomize the height, vertical 0.4 or something. Now after this point, what we can do is realize these instances and resample this curve. Let's add around 20 points in this one. This we are doing so that we can distort these lines. We need more points to distort these lines. There are all kind of trees, vertical, simple, flat one, twisted one, this and that. But just for the sake of making this look natural, we are going to bring one simple noise texture, which is going to add some distortion here. So as soon as we plug this here, you can see that the tree is kind of shifting this way, and we can simply fix this with vector math. Just subtract 0.5 out of this. It's just a thing with a nice texture in the Blender. And then you can add another multiply node just in case if you need to amplify this further. Let's make this one 2. And right now there's too much noise going on here. So we can scale this texture down. There are just a few waves good enough for a very little distortion here. After this point, what we can do is bring another instances on points and combine these two. So basically what we are going to do is we are going to instance a few more lines which are going to work as branches for us. So on the main tree trunk, we are instancing more points and joining both of these. These lines can be rotated in the tangent direction. So based on the tangent of the curve, you can see the rotation of these lines now. You can also use the tangent for the scale. It's just a good reference. It works. I mean, there are many ways you can figure this out. For the time being, let's plug this one instead of keeping everything straight. Now we don't want these lines, the branches on the entire tree trunk. Instead, in the selection, just use the endpoints, maybe 4 or 5. I think 5 is a good number for this. We can also randomize this. Instead of using all the 5 points, we can randomize this one. So now every time we generate a new tree, these values are going to differ. Now all we need to do is same thing, realize these instances and resample these branches that we have created here. These could be 6 points or something, and then exactly the same thing that we did here, add some distortion in the line. So these lines can be distorted too. But what's happening is this texture is kind of distorting the entire line. So what we want is the base to stick to the existing tree trunk. So for that, bring a node called spline parameter and use the length in the selection. If you control shift click on this any of the parameter that you want to visualize, it's going to bring a viewer node. After that, on whichever geometry you need to visualize this on, just control shift click that one. So you can see this value black and white, which is running on every curve. It's basically the length and the factor of the curve. So based on that, it's distributing this noise now that we have used this in the selection. Just like what we discussed in the curve chapter, I believe it was chapter number 8 or something. So pretty simple thing. Now we have few branches. Now if you look at the trees, what happens is basically you have the main tree trunk, then you have few bigger branches, then there are more branches which are instanced on those ones, then it keeps splitting further. So if you think about it, whatever we have done here, the same thing needs to repeat quite a few times. So if I make a group out of this with Control G, so this group can be called branches. Now if I duplicate this one, it's going to do the same thing. Take the previous lines, on those lines make a new branches and select the last few points. So if you need to jump in and out of the group, just press tab. So we are going to copy this a few times, 4 or 5 times. Yeah, this looks good. So you can see every time we select a new group, it's showing us the branches, the new branches, but at the same time we are not able to see the previous branches that were there. That's because these nodes are overriding the previous ones. So we are going to join these one as well in the join geometry node that we have here, so that we can see these as well. Exactly what we discussed in the chapter number 4 or the very first chapter, I think. So we have something like this going on here, right? I'm going to make this one 4D texture or something, and keep in mind whenever you're using a noise texture, use the color value, because if you use the factor value, this is not a vector. Color RGB is a vector value, so you can use that. It works in 3 dimension. If you use the factor here, it's simply going to make your tree look flat. Now that we have this formation going on, if we jump inside the branches and start playing around with these numbers, let's bring one multiply node and plug this into the curve tangent which we used for the rotation of the branches. Now you can see we can amplify this curve tangent node, and this sort of helps us spread this tree inside and out, something like this. I think I can make one more copy out of this. So just playing with a few numbers here. So this formation that we have here, with every parameter that you see here on the screen, we can change the look of this. If you make this one tall, this is going to change the look of the tree. If you reduce or increase the noise, that is also going to change how these branches, the split of the branches, how smoother or rough this is going to be. And at the same time, if we increase or decrease the multiplication here of the tangents, that decides the spread in and out of this tree, the vertical height, the random height in the main tree trunk. So all these small things are going to help us make n number of variations in the tree. And one more thing we can do here is, right before the set position node that we used to add distortion in the tree trunk, if we bring one more set position node, and this time instead of using a noise texture, we can use vector rotate and plug this one into the position. Just bring one position node and plug that into the vector. That's going to make this one a default position. Now what we want is, based on the curve parameter here, let me just bring this one. If we bring one spline parameter, plug the length into the angle, the higher it gets based on this number. This gradient basically on the curve is going to decide the twist that is happening in the tree. And this twist is happening, let me just get rid of this viewer node, it's kind of disrupting. So this twist we can tweak in many ways. You can decide from which angle it's going to twist, in which axis. So just in case if you need to make sort of a stylized tree, you can use this kind of a thing. So if we mute this one, it's comparatively a straight tree, and this one is much more twisted one. This looks fine. Now what we need to do is take these last points and distribute few leaves that we have here, form the main crown of the tree. So these last branches that we have created here, if I take this one and create instances on points, let's bring one icosphere and plug that here. Let's join this one with another join geometry node. I hope you can see it on the screen, and hope you're not watching this on mobile phone. On the last branches, we have these icospheres spread out. But instead of on every point, what we can do is just use the last endpoint. It's not logically a correct way of making an actual tree, but basically what we are going to do is distribute a few more points. So on each of these, we are going to distribute a few more points on which we can distribute the leaves that we have here in the outliner. All right. So don't worry about the shape of the tree. We can tweak that later but at the moment, let's just complete this one and then we are going to make a few variations out of it. Let's randomize these icospheres, and on these, let's realize these instances and instances on points again, curved line, and these could be pointing in the direction of the normal. But for this to work better, we need another node called align Euler to vector and just point in the z direction. Sorry, just plug this one into the vector. So now on every endpoint, we have a multiple of these lines, which can help us create a dense formation for the crown of the tree. Now all you need to do is bring another instances on points and just drag this leaf and the object that we have, and we can use tangent or something. We can also use a random node or something. I think these lines that we have made, we can randomize the value of that as well. Now the icosphere that we had made earlier, if we use more subdivision into this tree is going to get much more dense. But let's just keep it a light one at this moment. Now let's go to the render engine and change this to cycle. So this seems fine for now. Okay, let's leave it as it is. Now what we are going to do is add some mesh to the branches that we have made so that we can get a better visualization of the tree. For these branches, we are going to bring a simple node called curve to mesh and plug this right after the branches, not after this, because these are curves, these are solid geometries. So this is not going to work on those ones. So right after the curves, curve to mesh, and then bring a curve circle and plug that into the profile curve. Reduce the resolution to 6 or something. Let's keep it light for now and don't really get ambitious. So we have branches, but we are not really getting the kind of representation that we see in the trees. These should be thicker here, and as this reaches to the end, it should get much more finer. We can set radius for these branches. So these are the branches. Let's split this up. So now these are the branches. This is the tree trunk. Now if I bring set curve radius node, now that I have two different networks, I can use different values in both of these. We want this to get tapered in the length of the tree. So for that, spline parameter again, and connect the length to the radius. We can simply invert this with a color ramp node, flip color ramp, and then we can use a map range. Yeah, use the factor value here. That works better in this case. So this looks fine. Let's leave it as it is for now. And for the other thing, the branches, what we can do is these icospheres that we had created here at the endpoint for the tree crown, we can use this reference and use proximity node, geometry proximity. So if we use this in the radius, so based on the proximity, let me just cut this down for now. So I'm using Control Shift click to visualize these with the viewer node. It's a bit tricky node. It's a new one. If you want to preview any of these values, just Shift Control and click on this one, or right click, whichever click you're using. Now it shows the value, but in geometry we need something. So if we select this curve with Control Shift click, it's going to give us a preview on that geometry. This parameter, the geometry proximity, is helping us taper out the branches. Let's map range this one. So based on the distance from that endpoint, this is going to decide the thickness. So it's one of the way, and I'm pretty sure there are plenty of other ways to achieve this one. I'm pretty sure if you can some advanced vector math, you can come up with much more accurate results. But I'm not much of a math person, but that's okay. We should be able to make a pretty convincing tree by the end of this tutorial. So now we have a tree. I'm just going to reduce the twist. So now we have the basic setup of the tree. So what I'm going to do now is simply going to tweak a few number and find a better variation of this one, and then we are going to finalize it with the material or something. So every time I scroll these numbers, we should be able to generate a new tree. So just by changing the seed of the very initial the tree trunk, we can create so many variations, and we can map range this twist. And then we can jump inside the branches. Let's see if we can spread this in and out, set the scale of the line, and do all sort of things. Just for the sake of it, let me just assign a simple material. So the last bit of lines that we made on the icospheres, these lines, what I'm thinking is resample this and add some noise on this one as well. So set position and bring the same noise that used on every other thing and plug that right here. The spines which we are using to distribute the crown, the leaves, these could be slightly rough ones as well. So this is before this, after this, before and after. So as much as chaos we can add in this one, it's going to look even more natural. So I'm going to stop talking now, scroll these numbers and find a better variation of the tree now. Alright, so this looks pretty decent and we are going to make more variations out of it in a moment. So what we can do is first, let's just organize this one. Alright, so this is much better. So let's do a quick run through again and then we are going to talk about material and group nodes. So first we made one quick circle, a solid one. Then we distributed a few lines with instance node and realize instances and sample curve. After resampling, we added some noise in this one. We added some twist in this one. Although we are not using much of it at this moment, we'll make a variation out of it in a moment. And then we added some noise. Alright, so this is the tree trunk. And then we started adding more branches. The tree trunk is using a reference for the endpoints that we distributed here on the last branches. And we're using proximity of that to add some thickness to these, set curve radius. And this is using spline parameter. So simple as that. Now in the last bit of the tree branches, we distributed these icospheres because these have multiple sides. It would be easy to make this one a dense one without having to distribute many more branches and make it a heavy tree. On these we added some lines, realize these instances, resample these curves, add some more random noise to this. And then we instanced the planes which are carrying the texture of the leaf. Let me just get rid of this viewer node. Where is it? The viewer node. The stupid viewer node. Get out of here. And yeah, that's it. So this is the tree. Now what we can do is every time you need to work in this node network, you're going to be scrolling, panning, and making adjustments here and there. It's not really accessible and easy or convenient way. So we are going to make this one into a group node, which is going to let you access all the parameters necessary from right here in the modifier panel. And that is going to not interfere with the internal parameters here. So whatever you change here is not going to change any of these parameters here. So it's a much better way of creating a variations and dealing with all these numbers. So before we do that, let me just add a trunk material. And there's one more thing I want to clarify about how you can use attribute to shade trunk. So for the tree trunk, let's add some really basic material. I'm just going to select this material 001, go to the shader editor and start bringing some noise textures. So this is really not a great tree bark material or anything. You can bring some other textures if you want. I'm just going to explain one important thing here which you can do to shade your tree trunk. So this texture here, texture you bring, when you press Ctrl T with the node wrangler, you get this mapping coordinates. What if you wanted to create a tree bark or something like you have these twisted things? So I don't have a exactly precise method of that. There might be something which you could pursue further. Let me just show you a geometry node editor. So this tree trunk, so if I take this and distribute points on faces and then use these points with proximity. So let's see how many points. Yeah, sorry, use this curve to mesh and then decrease the density. We just want a few points on the tree. On the main tree, if you go to the attribute and click on the store named attribute, and let's plug this here. In this one, what we want to store is the distance data of these points proximity. Plug that here and call this one bark. Just for your visualization purpose, I'm going to increase the resolution of this tree and maybe set spline type to Bezier curve, set handle type to smooth, just exactly what we discussed in the curve section. So now in the shader editor, now that we have stored the proximity of these points that we made, let's bring one attribute which is called bark that we created in the geometry node. And if we mix these two vectors, the mapping coordinates and this one, now we can influence this texture and sort of create a twisted formation in the texture. So let me map range this. So for the factor, let's use this one and then map range this. Sorry. So wherever our points are, we are going to see some twisted formation there. Let me just, let's see if I can make this one slightly better. Instances on points. Join this one here. Icosphere. So these points that we created, the distance data of these points. Yeah, sorry. So far it was not working. So now it's working. So we are actually influencing the vector coordinates by mixing radial influence of these points, and that way the whole vector of the texture is kind of getting twisted. So something like this can be used to form the tree bark. All right, so I hope this helps. And now the very last thing that I'm going to mention here is how you can make this one into a group node. All right, so the very first node that we deleted, which was connected right here, this group input, and then you have group output here. So just bring that node Now start plugging any of these numbers which are making significant changes in your tree, and just start scrolling these numbers and see what they are doing. And then you can plug those numbers here and name those parameters with some property which are easy to identify, and then you don't have to go back in and out and work on this entire map again. So the very first thing is the density, which is the density of the tree trunk. So let's call this one click on the groups here, right here, this one, trunk density, and then you have a seed, so drag that here, name this one trunk seed, and then you have the height of the tree. So this you can separate with separate xyz, combine xyz, and then use this number here. Now you can see whatever group inputs we are adding here from the modifier panels, you can access these. So these are going to pile up here. And a few more things, random height in the trunk. We can use this number if you want, but let's try to keep it simple at this moment. We don't really want to get into the details of this. It's going to be really lengthy chapter. Just for the example, so this is the twist to maximum. This is the twist. And let's call this one tree twist. And then what else do we have here? The tree distortion. Let's drag this one. So let's call this one trunk noise. Then you have a few parameters inside this, and these you can plug here, and from here you can redirect here if you want. So this parameter here, let's plug this one. So now you have this value right here. Let's plug this value. I think we can bring group input here as well. So we can bring another one here. Yeah, so you don't have to connect everything to this group input. So you can make another group input node, and this vector value that we are plugging is for the spread of the tree. Branch spread. So for now, we are going to just settle with these numbers here. Now that you have all of these, you can save this asset in the asset library. So there are two ways of saving this. One, if you go to the asset library, the first thing you need to make sure that from the edit and preferences, that in the file path, you have some set path for the asset library. So in my case, it's set to downloads Blender assets. Now just make sure you're saving the file into the same directory. And now in the outliner, if you click on the display mode and change this to, instead of view layer, change this to Blender file. Now this is going to show you all sort of data blocks that you have in your scene, the brushes, this and that. So in the node section, node groups, you can see our tree generator is there. If you right click on this one and mark as asset, this is going to appear in the current file, but in the user library as well, tree generator. So you can save your file here, or what you can do is, if you select this object, you have this object called plane. Let's call this one tree final. You can right click on this one, mark as asset again. So now you have this node group and this tree final. Now let's go to the new file and bring our asset browser. So from your user library, if you drag this tree final object here, this is going to give you the tree that we made with all these parameters here. Everything is there, all the material and everything. Then everything is good to go, and you have your tree, and from here you can tweak any aspect of this one. And if you go to the geometry node editor, then you have the entire thing right here. Now what's the difference in this one and the other tree, the node group that we saved? So let me just show you. So let's assume you sort of created a generator which works on an object. Let's say it distributes a grass on an object or something. Then in that case, you can use this node group. So instead of bringing the entire object, you can save your node group as well. So if I drag this, so this tree, I think it's a different one, but anyways, so this tree you can drag in and on top of your geometry it's going to regenerate whatever node network inside whatever you have made inside of this. So in this case we have just made one tree, so this doesn't make sense. So let's say if you had stones or something on top of this, we want to spread some grass or rocks, so we can add some rocks here, and there you go. Group input, yeah, and you have your rocks on the mesh that is beneath it. Similarly, I think I also had made a grass thing, but I think in the next chapter we are going to do more. So this is how you can save your assets, whatever you make with the geometry node. I think this is a very powerful way of working. So every time you think of a tree now, you won't really have to work from the ground up, from the scratch. Just bring your existing tree, tweak a few numbers here and there, and quickly visualize this. Your material is set. And this is definitely going to save you at least 15 minutes or half an hour or something, or maybe more than that. What you can do is make a duplicate of this and you have one more tree. For this you can change the seed, trunk seed, and you have another tree. So similarly I made this tree with the exact same method, and with the similar methods I made grass, the rocks and all that, and with just a few clicks and drops I was able to create this scene. So in the next chapter we are going to talk about a few more generators, how you can populate your entire scene just by by clicking on the few numbers. So this is going to be our next chapter. A few more details we are going to discuss in the next one. So that's about it for this chapter today. So I hope you find this one useful, and I hope this adds some more depth to your knowledge about the geometry nodes. In the way we have been progressing, we have been discussing a few simple examples, then slowly working our way towards the procedural stuff. This is not really a non-destructive tree. I think this tree is not made in a perfect way, but it's quite convincing enough, and it at least clears out a few of the principles which are about the geometry nodes, how you can put a few thoughts about making a thing which can turn out to be a much more powerful generator rather than having a static model. So that's the thing I wanted to discuss today, and hope this clears out a few doubts, and also hope this is easy to follow along. And I would suggest that you try and make a simple tree and not such a dense tree. Work with the very initial few steps that we discussed, forms the main trunk and the branches. After that point of time, it's going to be just about scattering the tree leaves and all that. For those of you who have stumbled upon this chapter randomly, please go back and watch the previous chapters if you're new to geometry nodes for this to make sense. If you have seen the previous tutorials in the right order, this would be much more easier for you to grasp. And for your information, we have just started a Discord server, which is not completely finished yet, but I'm hoping once the crowd kind of gathers on the server and it's up and running and more people are working on the server, so based on the feedback and everything, everyone's inputs, we are going to make changes. So it's a thing now. You can discuss whatever doubts you have, you can contribute on participate in the activities on the Discord server. There are a few things happening. The link is right here in the description. I'm going to leave this file and all the previous files from this project, the geometry node course, are there on the Gumroad. So if you want to just explore a few things in the files, you can just download these files from the link in the description. Yeah, that'll be also a great support for our channel. Thank you for tuning in. Take care. Bye bye. I'll see you guys in the next chapter. Bye.